Okay. So we now know how to use central limit theorem to find the probability. Here is another version of the problem where we want to estimate the probability that the first 100 customers spent a total of between $780 and $820. So which means that we just want to find what is the probability that the total amount or of order is going to be between $780 and $820. What is the probability that the owner will have this income for first 100 customers? Okay, so that's all. So now what you do, again, you will have to use Q table because in the exam you will not have computer. So, second part of the example is we want to find the probability that the total of all orders from 100 customers between $780 and $820. Now, guys, yeah, just take a look. You'll be able to figure this out in a moment. So just take a look the formula that I will be using. We went through this formula. So it is the fourth step, convert to standard normal probability. So if to approximate this probability using sum of all the random variables, you just use this formula. You simply use this formula. So you have A, you have B, and then you have standard CDF. So you just pass this to standard CDF, and standard CDF has relation with the Q function as such. So yeah, it is basically this formula, and we have. So can you write it down, guys? Phi B minus n mu over sigma square root over n minus phi A minus n mu over sigma square root over n. We will straight use this formula. Straight application of this formula. Because we already know this upper limit and lower limit of this event. Okay. So I'm going to approximate it because 100 customers and phi assumes that you have infinite number of measurements, so that's why it is going to be approximation. And I'm going to write phi of B minus, what was the formula? B 820 minus n mu. 100 times 800 over 20 less this minus 5 A minus n mu. What is A? A is 870. 780 actually. 780 minus 800 over 20. So direct application of the formula. So we have how much is it?
One.
20, right? Or yeah, 1 actually.
One.
1 minus 5, how much is it?
Negative one.
Negative 1. Okay. Do you recall that what is phi of negative x? Phi of negative x is basically q of x. And phi of x is basically 1 minus q of x. So we write it in terms of q because you have access to qt. So you have 1 minus q of 1 minus q of 1, which is 1 minus 2 q of 1, and q of 1 is basically q of 1 is basically 1 minus 2 times, it is 0.1587, and that would give you approximately 0.6826. So I'm just going to have one more. So probability that 780 less than S100 less than 820 is going to be 0.6826, and that is the final answer. With that, I conclude chapter 7. So that concludes actually chapter 7. So central limit theorem is the last topic of chapter 7, and from chapter 7 I covered only 3 sections, section 7.1, 7.2, 7.3, and whatever I covered I summarized in my slide. Yeah, there are some advanced topics that I utilized when I worked for government. So there are some advanced topics of convergence in distribution, convergence in distribution, convergence in probability, convergence in and almost sure convergence. And people in mathematics, people call it AE. Almost everywhere or almost sure, almost surely, or almost surely, almost sure convergence, almost sure, almost everywhere. So this sort of acronym people do. So these are bit advanced topics that I will not go through, but I am going to conclude chapter 7 right on central limit theorem with this example. So make sure you practice similar examples from the book. Now I am going to move on to giving you some hints, a review on the exam. So I'm going to momentarily turn off the display because I'm going to open the exam, and I will make sure that I show you on the account. will still modify it, but the cover page will look like this, and you know how many problems you are expecting, right? So 4 problems, you are expecting 4 problems. You are allowed to bring 1 page of formula sheet, both sides. No worked out examples, just the formula, guys. Just formulas. And I will talk about the Q table in a moment when I give you. And the Q table you can bring. Okay? Hard copy of the Q table. And we'll have the exam in, I'll send you an email, it's going to be on 40 to 61 junior level, not here. So you'll have 4 problems. You guys know my style. You have your first exam, so second exam is going to be very similar, only topics will be different. So let's see. Okay, I'm not going to scroll down from. We'll start from slide number 1.137, probability density function. We did cover the cumulative distribution function. We shall start from probability density function. So it is slide number 137. So you'll start right from here. Make sure you revisit the computer experiment. We'll have like very simple Python problem, 1 or 2 lines of code, three or 4 lines of code maximum. So revisit your Python code that you use for computer experiment pertaining to probability density function, and bring some formulas, and then go through all the homework problems. Okay, I included all these examples in the homework problem and some end of chapter problems. You submitted homework problems already, solution, and you got good grade. Make sure you revisit them. So I am not going to, in case you have some Python related question, so most likely you will be using scipy.stats module. Okay. Scipy.stats module, 3 or 4 lines of Python code, but I'm not going to ask you to plot. Okay. I'm not going to ask you to plot data. Main comments that you should focus is this one. And exponential distribution, so we went through that in class, but main focus is going to be Gaussian distribution from chapter number 4. Very important. Gaussian distribution, I went through this. I spent significant amount of time explaining this Gaussian distribution. So forget about Gaussian integral, there will be no proof like that, but you will be making use of properties of standard Gaussian random variable, CDF of standard Gaussian random variable, and how this is related to the Q function, and then you will be using, I did, like again, pay attention to this code, what this code is doing. Again, no code related to plot. So, this Q table, you can bring this Q table here, or you can download it from the author's book as well. So, this Q table, it is actually chapter 4, table 4.2. I actually copied and typed the text here to look nice. Yes?
Are we allowed to table
two pages, the formula sheet front and back.
Okay.
Yeah, formula sheet you can front and back. And so this is one version of Q table. There is another version of Q table, is this one. Okay, so you bring this table and this table. So it's two different version of Q table. In case you have X, you know approximated QX. And then if you are given Qx in the form of 10 to the negative k, you can directly find Xx from this table. In case Qx is in the form of 10 to the negative k. Okay, and yeah, this example, I went through this example in class. How to yeah, so actually look at this probability that we have A less than or equals X less than or equals D. We already solved this sort of probability using Q function. But the example that we just solved is based on still we are finding this probability, but after we formulated it to be a central limit theorem. So we went through this conditional CDF, PDF. We did not go through this conditional CDF, PDF. So we went through the expectation of continuous random variable. So we went through this expectation of continuous random variable. We went through this. Forget about proofs, guys. All problems will be numerical problems. So these proofs are just for you to understand why I wrote this expectation. So I have all these proofs. We have solution of this example. So we went through the solution, and then here we have a summary of some random variables, exponential random variable, Gaussian random variable. We have a summary of random variable. You may want to bring some formulas right from here. Functions of random variable. So this is very important. Functions of random variable. We went through this in class. So these are continuous random variable, and then method of transformation. So we have linear transformation. We went through method of transformation. You follow that. And then you had one extractive problem. Extractive problem pertaining to this. So make sure you know how to manipulate linear space, how to make use of linear space, and how to make use of PDFs. So after that, Markov and Chebyshev inequalities, I did not go through this in class at all. So you may want to just skip all this. So let me tell you exactly where you stop at slide number 193. You stop at slide number 193. You start from slide number 137, and you stop at slide number 193.
But when you start?
137. 137. Yeah, so right from here. So now, let's move on to chapter 5. Chapter 5. Yeah, don't forget to study the initial introductory slides, because you may expect some true-false type questions. Okay. So these introductory slides, make sure you go through this. Now, we actually went through this example, this concept, but I'm telling you, I'll go through all the examples, but I'm telling you the most important topic. So here, so the CDF of two random variables. Example very similar to 5.5, maybe some. But I'm going to make sure that the 4 problems you can finish it in 15 minutes. Okay? So the problems will be adjusted accordingly. So these examples, the CDF, how to complete CDF of 2 random variables, very important. Marginal probability, marginal CDF. So marginal CDF. So marginal PMF, and then marginal CDF. So we come up with joint CDF, and then from joint CDF, we know how to determine the marginal CDF. Okay? So we know how to find the joint CDF, and from joint CDF, how to find the marginal CDF. So this example I actually extracted the previous example, and then we came up with this example. So as you see, this is not from the book. I just modified the previous example and came up with this example. Make sure you go through the solution, and don't forget to solve the end of the chapter problems. The practice problem that I put in the homework and in the beginning of computer assignments. So in the exam, you will not be able to show me like 3D plots like that. Okay. So in the exam, I'm expecting it to be mathematical expression of CDF. So how to represent CDF mathematically. Yeah, this example is very similar. I did not solve this at home, in the class, but we did go through this example. You did go through this example for your homework, because I have this example in the homework. Okay, now we are moving on to joint PDF. Joint PDF, probability density function, and among all these examples, among all the examples that we went through, okay, so the most important topic from this chapter is going to be jointly Gaussian random variable. Jointly Gaussian random variable. How we define the jointly Gaussian random variable. So you define the jointly Gaussian random variable, how to come up with marginal PDF given the joint PDF, and then we have the example. Make sure you pay attention to the loaded dice or unloaded. Okay, then you know, even though there are it's 6 by 6 square to represent the joint PMF, but make sure it is not 1/36. If you pay attention, most of the time people make mistakes because they simply omit the repeated sequence of diagonal elements. So that's why you have extra 6 outcomes. So independence, the conditions of independence, you can write down in the formula sheet, but you will be making use of through some problems, numerical problems. For example, we have the joint PDF, find the condition under which the joint PDF will be multiplication of some individual, the multiplication of individual PDFs of two random variables. So we skipped that, and then we went on to joint moment and expected values of the function of two random variables. So very important. So we have simple examples. These simple examples. So this example I put it as part of your homework problem. This one as well. Okay. So if you solve your homework problem and end of chapter problems, lot of practice problems will be done over it. So it's going to be 2 birds with 1 stone. Now we have joint moments. So we have formula for joint moments, correlation, how to define correlation, how to define correlation, how to define central moments with some numerical examples. I went through numerical examples, even though formula look complex, but I am actually using that formula through some very, very simple numerical example. So make sure you solve this example. Now, from there, I explained clearly the covariance of two random variables. So it's basically J equals 1, K equals 1 central moment. So you find the covariance of two random variables. Now, covariance greater than 0, what does that mean? Covariance greater than 0, what does that mean? Covariance less than 0, what does that mean? Covariance equals 0. Okay. So all this meaningful information you should know for the sake of proof of step question. And covariance boils down to correlation. Under what condition? Covariance boils down to correlation. So this is basically correlation. If any of the expectations or any of the means of two random variables is 0, then covariance becomes correlation. So here we have another example, graphical demonstration of showing how covariance, what covariance means graphically. And then finally, after we have all of this, finally we define the correlation coefficient. In statistics, very important this parameter, correlation coefficient. Correlation coefficient, here I showed the difference, I showed you for two random variables correlation coefficient. We did not go through vector random variable, which is chapter 5, but for two random variables, I gave specific formula for correlation coefficient. So you should be able to get numerical values of correlation coefficient. So to find the correlation coefficient, look what you have to find. You have to find the covariance of x, y, and you have to find the standard deviations of random variable x and y. In other words, if you don't know the covariance, you can, if you know the correlation and if you know the individual means, you can still, individual mean and variance, you can still compute the correlation coefficient. So there are several ways to compute the correlation coefficient. Now there are some characteristics of correlation coefficient. So if correlation coefficient is greater than 0, it's positively, two sets of data will be positive, two random variables will be positively correlated, negative 0, negative correlation, and rho equals 0, which means that the data, the two random variables that you have data from will be completely uncorrelated. So very important, this characteristic equation. And finally, that is the last example that we went through in chapter 5. And after that, I did not go through it at all. I did not go through the other functions. So this is the final example that I went through in class. And here, this example, what I did, actually last year I did not modify much. So here, I provided you the complete solution of 5 parts of this example. So you have to do a little bit of integration, some math, calculus. Okay. So you have the joint period and find the normalization constant and marginal periods. And I gave you the complete solution. Complete solution. So even integration. Please do not simply skim over this solution because you have the solution. Do not simply skim over the solution. Take a piece of paper and then write down the solution. Okay? That way you will have good practice. So I customized this example to summarize all the theory on joint PDF, jointly continuous random variable that we talked about. So it's very important here we talk about correlation, how to find the correlation, how to find the covariance, how to find the covariance matrix. Covariance matrix, which is sigma. It is called sigma xy, like summation symbol, but it is Greek symbol sigma. So how to find the covariance matrix, and then finally correlation coefficient. So we have part 1, part 2, and then part 3, part 4, part 5, correlation coefficient. So I came up with a simple plain and simple numerical example. Okay, so make sure, please do not simply skim over the solution. Take a piece of paper and then redo this solution. All right, so after that, I did not go through any of these topics. What I did for the rest of the topics, what I did, I actually covered this part in the computer assembly. So please do not simply skim over the solution. Here, make sure after the example, the rest of the theory, I actually summarized everything in this section. Jointly Gaussian random variable. Make sure you go through this part. So this is available. This is on Canvas. Okay. So this is on Canvas. So go through this theoretical section for you to understand. But the most important part here, you see like how I came up with this covariance matrix. So the most important part. So these are some theory generating random samples from two random variables. How I use standard Gaussian random variable to generate samples for any random variables. So this is part of your computer assignment, estimating signal from its noisy measurement. So all the theory has been given. Now what you have here is make sure you go through this example as well. So this example is based on the theory that I went through here. So you have mean, variance, PDF, find the covariance of X. Very similar to the example that I have in my slide. If you just follow similar style, then you should be able to solve this part as well. And this part has direct impact to your computer experiments. So computer experiments, you have 5 parts, and this should generate 7 figures. This should generate 7 figures for your computer. Okay, so this computer experiment is due on Friday as well. But Friday, because we have exam, I can push it back if you want. Do you want or not?
Yes. Yeah.
You don't want? He doesn't want. Okay. So, yeah, that's okay. I can. It doesn't bother me. I can just push it back by 2 days. So you prepare for the exam. Okay. So I'll change actually. I'll change the due date of this. So you do good job in the exam. So I'm extending this due date. Slight modification from the schedule that I posted initially, but it is going to be on Monday. So just to reiterate, guys, don't forget the theory that I have here. So just this theory that I have in the computer experiment in as part of the preparation from chapter 5. So that's all from chapter 5, and then chapter 7, which is part 2. Part 2, what I basically summarized today. Yeah, part two basically I summarized today. Some of you were absent last Friday, so I actually went through right from the beginning. That's why I was able to cover chapter 8. But we went through this example, and the main topic that we covered today is central limit theorem. So central limit theorem, this is the most important topic from chapter number 7 or part 2. Okay, so you stop at slide number 225. From part 2, you stop at slide number 225. Again, part 2 we covered laws of large numbers, sample mean, sum of random variables, introduction, we covered that. So among all these topics, the most important topic is the central limit theorem. Okay, the most important topic is the central limit theorem. So please pay attention. Let me know if you have any question regarding the computer assignment or homework assignment or any theory that I have posted. Okay, I have office hour Tuesday, Thursday from 11:30 to 12:30. You don't need an appointment to meet during my office. And yeah, that's all. I'll see you on Friday, and expect an email from me for the exam to be in our junior lab, which is 461. Thank you very much.